Hey guys, it's Landon with Taught by a Surveyor. This is another geometry video we're doing on circles. This time we're going to talk about circles and touchy-feely lines. The reason I call them touchy-feely lines is because we're going to talk about lines that touch the circle. If the lines don't touch the circle, we don't care today. We're not talking about them. All right, so before you watch this video, go back, watch the video, the first video I did about circles and circular arcs. You need to understand those concepts before you watch this video. So today we're going to teach about secant lines and chords. In this video, we're going to talk about tangent lines, radial lines, tangents and radials, and the relationship between those, and then chords and right triangles, overlapping right triangles. Oh my, sounds very scary. It's not scary. Don't panic. It's going to be fine. All this will make sense, I hope, at the end of the video. I've tried to touch up my circle diagram from the last video a little bit. So let's go ahead and dive right in here. I think I spelled secant wrong. I apologize. That's why I'm teaching you about math and not spelling and grammar. Secant with an A, I believe. Okay, so what is a secant line? A secant line is a line that passes through a circle and touches the circle at least 2 points, okay? So you can see we touched the circle here, and we touched the circle here. Now, I called it a line, but you can really think about this as like a ray, right? It's really a ray. So it goes on forever and ever in each direction. The part of the secant ray or line that falls inside the circle is called a chord. So another way to define a chord is a straight line that touches 2 points on the circle. So the diameter that's a special chord, right? It's still a chord. It touches the circle at 2 points, but the diameter always also goes through the center. So a diameter is a chord. All diameters are chords. Not all chords are diameters. Okay, you can win lunch money with that trivia question the next time you're hanging out with your buddies or your girlfriends, either one. Okay, so let's see here. We talked about secant lines and chords. Tangent lines. Okay, so tangent lines are not like secant lines. So secant lines always cross the circle and touch it at 2 points. A tangent line barely touches the circle. So it only touches the circle at 1 point right here. Okay, 1 point. Okay, so it never actually crosses into the circle. It never goes inside the circle. It just kisses. It just kisses barely kisses the outside of the circle. That line is called a tangent line. Okay, and we'll talk more about that when we talk about tangent curves and non-tangent curves. That's a surveyor thing we'll talk about. So you know what a secant line is now, and a chord. You know what a tangent line is. Okay, a radial line is any line. I think I talked about this in a first video. A radial line is any line drawn from the center of the circle to the edge of the circle. We call that, surveyors call that a radial. I don't know if that's an official geometry term, but that's what surveyors call it. We call it a radial line. Okay. Now, the reason I wanted to tell you about radial lines is because there's a special relationship between radial lines and tangent lines. So whenever a tangent line touches the circle, wherever that happens, that point, if you draw a line from that point to the center of the circle, that radial line and that tangent line form a 90-degree angle. Okay? And we know from the other videos at Taught by a Surveyor that 90-degree angles are special, right? We can make 90-degree triangle. We can make right triangles out of 90-degree angles. Okay, so it doesn't matter. Anywhere you draw a tangent, if we drew another tangent over here, the angle from that tangent line to the radial line that connects to the tangent at that point where it touches the circle, that angle is always a right angle. It's always 90 degrees. Okay, so that's a special property of tangent lines. Okay, let's see, what else do we want to talk about? All right, we want to talk about chords and right triangles. Okay, so I'm going to get a different color here. I'm going to draw in a chord. I'm going to draw the chord of that arc in. And we're going to do a whole nother video where we talk about circular arcs and the way surveyors use circular arcs, but this is just a kind of an introduction to that. So I'm going to draw in the chord here, as straight as I can. Okay, so this is the chord. I feel like I kind of bowed my purple line down a little bit to get around that lettering. Let me try it again. That's a little better. Okay, so that's the chord. Okay, so there's a couple sets of right triangles in this little pie slice here, formed by this arc and these two radials. Okay, so if I'm going to draw a line from the radius point of the circle through the midpoint of the chord to the midpoint of the arc, okay, and now I've set up 4 right triangles. So there's a right triangle here, there's a right triangle here, so this is a right triangle, and this is a right triangle, okay, and then we actually have another right triangle, 2 more. So then, let's see, if I draw this line through like this, so if I go like this, I just connect the end of the arc to the midpoint, okay, let's see, nope, I did that wrong, I'm so sorry. I'm sorry, if I extend the tangents, that's what I wanted to do. If I extend the tangents down to where they intersect, okay, then I get 2 more right triangles. Okay, then these triangles right here are also right triangles. Okay, so just to count them, 1 right here, 2 right here, 3 right here, 4 right here, 4 overlapping right triangles, and surveyors use those 4 right overlapping right triangles to solve, and calculate all kinds of tangent curve, arc problems, coordinate geometry problems. I'm going to do a whole nother video on that. I might do a couple videos, but I wanted you to just understand these relationships here between radials and tangent lines and chords and the right triangles they form are important, and surveyors can use those to solve problems. Okay, so that was this last one, chords and right triangles, those 4 overlapping right triangles. Now, we'll talk some more about that specific set of 4 overlapping right triangles. There are also some other kind of interesting properties about circles and touchy-feely lines. So there's I forget, there's some like theorems or some rules about lines that touch or intersect circles, which are kind of cool, and they can be used to solve problems, or you can use them to stump your friends and win lunch money if you want. So I will do, now I don't know them by heart, so I want to brush up on them a little bit. I know a couple of them, but I want to brush up on them a little bit before I teach them to you. So we'll do that in a separate video. We'll talk about some of the special theorems of circles and touchy-feely lines, and I'll explain those. I'll explain those to you, and I'll try and explain a little bit about why they work. Okay? Thank you for watching. If you like the videos, don't forget, hit the like button on YouTube and subscribe to the channel. And thank you for watching.